Hi everyone, welcome to Building Service Ownership using documentation, telemetry, and a chance to make things better. Before I start, just a quick introduction. I'm Spoons, or Daniel Spoonhower, but everybody calls me Spoons. I'm the CTO and a co-founder at Lightstep. Before I founded Lightstep, I was an engineer at Google where I worked as part of Google's infrastructure and cloud platform teams. And I work closely with SRE to help build scalable tools and processes. I carried a pager for many years, both at Google and at Lightstep, and I still work closely with the foundations team at Lightstep, where our SREs sit. I've learned a lot of things, sometimes through osmosis, sometimes through failure, and I wanted to talk today about some of those things, both that I've learned from my own teams and from others as well. I'm also the author of Distributed Tracing in Practice. I work on and I write about tracing because I think it's really important to the way that we develop and operate systems today. And maybe not surprisingly, I'm going to talk about how tracing can be part of how we can build and maintain service ownership. So some background on how we got here. So maybe this is ancient history to some of you, or maybe I'm just showing my age, but in the beginning, the relationship between SRE and dev was simple, or at least it was as simple to draw. And as organizations grew, we needed to scale, and maybe the picture started to look a little bit more like this. That is, if you turn your head sideways anyways, it's kind of a horizontal scaling. And I don't know about you though, I work in an organization now that looks a little bit more like this. That is where we have a small set of engineers, maybe SRE, maybe platform engineers, maybe infrastructure engineers that work to support the rest of the organization. And this is going to require a new kind of scaling, right? That is, as SRE, now we're in a place where we have to scale ourselves. So if we're going to maintain overall reliability, how are we going to do that sort of in the fact of this ever increasing rate of change and even ever increasing rate of change per SRE? Of course, that rate of change is going up because we've done things like deploy Kubernetes, we've started building microservices, and then more microservices and more microservices. And these are technical choices that we made to increase that rate of change, right? We broke the application into these smaller pieces that could be independently deployed so we can deploy them faster. And hopefully each of those deployments is less risk. But we have to understand how do we map that software architecture into this organization, right? Now that we've built these independent, loosely coupled distributed pieces, we need to understand who within our organization is responsible for them. And so one way of thinking about this service ownership is really about taking a distributed system and creating distributed ownership. Let me define service ownership, at least the way I think about it. And that's, in short anyway, just where developer teams are responsible for the delivery of software and service. So that means they're not just responsible for activities like writing code and fixing bugs, but also things like incident response, cost management, maybe capacity planning, that sort of thing. Everything throughout the software development lifecycle. You might think of this a little bit like DevOps, but DevOps can mean a lot of things. And really, I like to focus on just the ownership part here and this responsibility and the accountability that goes with it. If we get this, then hopefully that increased independence will lead to higher velocity. That's part of what we want here, right? And as well, maybe we give these teams the ability to make decisions autonomously, and hopefully that'll get us to some better outcomes because they can make choices that are more appropriate for their users or their software or their teams. So those things are all great, but I said we need them to actually take that responsibility so we can scale ourselves as SRE. So how are we going to get them to do that? Well, first, we can't have that independence if we don't set clear responsibilities and goals for them, right? We have to point people in the right direction if we expect them to go. And we can't scale that unless we have consistent ways of measuring that progress in those outcomes, right? If we're going to allow folks to make these independent and autonomous choices, we need ways of actually judging the performance and the outcomes of those things. And finally, if we're going to ask engineers to take on new responsibility, especially responsibility around on-call, we're going to meet some resistance to that unless we give teams some agency to actually control and to change the software and the processes that we're asking them to take on. So this leads me sort of to the three theses that I want you all to take away today. I used the word accountability and responsibility before, and accountability is important, but I really think it's only half of ownership. I also said agency, and I think that's really important. And I think the half of ownership that we often forget, that is, we have to give teams the means to actually improve things, to improve the way they work. And there's one thing I'm going to say over and over again is that if we're going to get service ownership to stick, we've got to do things in a consistent way. The second thing is, if we're going to make this scale, that is, if we're going to make it so a smaller SRE or platform team can support many teams owning services, we're going to need to automate. And that's not new to us. We're used to automating, but we're going to need data from the application, that is telemetry, and especially telemetry in the form of distributed tracing, to really automate in a way to make service ownership effective. And finally, the bulk of the talk, I'm actually going to talk about these three aspects of service ownership: documentation, on-call, and service level objectives. And these are not the only parts of service ownership. There's certainly other things as well, but these are things that I think are really important and can really get you moving towards service ownership. Before I dive into that, though, let me take a minute to talk about distributed tracing. I just want to make sure that we're all on the same page here. If you're familiar with distributed tracing, then bear with me for a moment. If you are familiar, you've probably seen something like this, or maybe like one of these. These are all different tools that visualize traces in some way. And they all have this sort of Gantt charty feel, right? You see a kind of colored bar of some sort that represents the work done by one service, and time goes from left to right. And as you go down the stack, you kind of go down the page from top to bottom. These are all individual traces. And as I'll talk about in a second, you can do a lot more with distributed tracing as well. If I'm going to define it in words, traces are a form of telemetry based upon spans with structure. You can also create distributed tracing using structured logs, as long as you have kind of the right IDs to tie things together. But this terminology of span comes from some work that was done by one of my co-founders at Google, and it actually is used in a lot of the other open source and other distributed tracing that's in industry today. But really, if you see it, it's a bit of a jargon. It really just means a timed event that describes the work done by some service. When you take those spans and you put them together, you get a trace, and you can use that as part of tracing to understand how requests are processed by services from end to end. And one of the things that's really cool and critical about traces is that they include a bunch of other metadata, like events or logs and annotations, or sometimes called tags, that tell you more about how the request was handled. And the thing that's different, whatever you call it, the thing that's really important here is that instead of thinking about telemetry and performance from the point of view of, say, a host or an instance or a container or a process, we're looking at kind of from the other angle, right? We're looking at it from the point of view of the user or a request. And so, yes, absolutely, many of those instances or processes will contribute in some way to handling this request, but the request is really giving us context for understanding the impact of that performance and whether or not and how it affects what users are perceiving. I said that spans are timed events with structure, and the important part of that structure is really about the relationships that they encode. And in particular, that as you go down the trace, that's really encoding these calls, and as you come back up, those are the returns from those calls. And so in that, traces encode the causal relationships between callers and callees, and so you know where responsibility for handling a request begins and ends, and you know how to attribute failures and other problems. I said, so, the traces are kind of the building blocks of what you can do. Another way of saying that is that they're just the raw material, not the finished product. So the traces are really just these structs. They're just the data, the raw telemetry. And tracing is really the art and science of getting value from those things. And so some of the things I'm going to talk about later in this talk are really where we take groups of traces and we do an analysis, or we use them in some way to understand more about the application or to automate some process in some way. If you want to learn more about that, you can check out the Dapper paper. This is a white paper put out by Google that describes Google's internal tracing system. And it's a bit old, but it's informed a lot of the open source work that's been done since then. You can also pick up a copy of our book. All the royalties go to charity, so I encourage everyone to do that. But it's a great both introduction to tracing and what it is and how you can get started, but also what you can use tracing for, how you can get value from it, and even where tracing is going in the future. And finally, if you're thinking about deploying tracing in your system, I strongly encourage you to take a look at OpenTelemetry. OpenTelemetry is an open source project that's part of the Cloud Native Computing Foundation that describes how to get all forms of telemetry, traces, metrics, and logs out of your application in a way that's vendor neutral, and in fact neutral even for other open source projects, right? So it defines an API, a set of SDKs, a wire format, some other tools that you can use to generate and start building that pipeline. Okay, so that's kind of tracing. If you want to find out more, check out these resources. From now, I'm going to kind of dive into service ownership itself. So I said there was these three parts that I wanted to look at: documentation, on-call, and SLOs. And when I say documentation, really the point is here that I'm talking about creating shared and written artifacts. And I know that, maybe we're just thinking about the README and things like that. Really, what I want to do is think about how do we put information together in places where people can find it, right? And I know that sounds a little bit like apple pie, like everyone sounds like a good idea to everyone, but I put it first here because I think it's really the starting point for establishing service ownership. Okay, so like I said, we want to take that documentation, we want to put it in a place where everyone can find it. We want to centralize it. And as we grew at Lightstep, as I'm sure a lot of your organizations have grown, we look to divide responsibilities, not just on call, but other things as well. But before we could do that, we had to know who the experts were, and we had to know what the responsibilities were too, right? So we started these wiki pages where we would describe each of the services that we have. Here's one of our services, and for each one, we would list the expert for it. We would start to list a bunch of other common information that others wanted to know. So if you find this page, you can find the expert. Maybe you don't even have to find the expert though, because this is where you can find links to telemetry and dashboards, to alert definitions, playbooks, things like that. One of the other things that we did that I think was pretty useful is that we use a template for this, right? So not only is that a way for us to define some, to provide for some consistency, but it also actually let us extract information from the documentation in automated ways as well, right? So we could do things like, run reports about, is this complete or not? Are all the sections filled in? Who is the expert? How is expertise distributed across the organization? And because it was all in one place and had the structure, we could also do things like track last modify dates, right? We can require periodic updates or audits to understand, how fresh our documentation is, and make sure that we've scheduled time to maybe double check and see if it could be improved in some way. And if it's all in one place, you can understand how it's changing in some way. Okay, that was sort of the first step. And this is, as we started to break apart ownership, sort of where we looked to see where those experts were. The next thing we did was we took that documentation and we started to make parts of it machine readable. So this clip here is part of our services.yaml file. This is a list of every service at Lightstep, along with a couple key pieces of information about that. And this is then used by a bunch of other processes. So yes, if you want to know the owner, you can go here and you can look at things. But this is also used to generate things like dashboard configuration, escalation policy configuration. Even our deployment pipeline is configured from this file. And what that did is that it meant that the documentation is now a sort of a necessary part of day-to-day work. It's not something that I just go and update once in a while. It's not something that I go to only, if I need to learn something. I actually have to go there when I want to get other work done, right? And this helps to ensure that it's up to date. So at Lightstep, we know that every service in production is in this file, because the only way to get a service into production is to run it through our pipeline. And the only way to get it into the pipeline is to add it to this file. The last thing we did, and that I encourage others to do, is to make that documentation dynamic. So, we started with documentation written by humans for humans. We figured out how to take it and also consume it by automation. Now we can actually use automation to generate some of that documentation. And one of the hardest things in almost every org that I've worked in is maintaining the list of dependencies for each service, just because the software is changing so fast, and especially when you think about second and third degree dependencies, because the number of those is far greater than any one team can keep track of. And so rather than trying to keep those up to date manually, rather than trying to have that whiteboard where you keep your system architecture up to date, I've tried that. It doesn't work, and it's not great for your remote employees. What you can do though is that you can use telemetry from the application to reveal this kind of information, right? So you can use traces in aggregate to build diagrams like this to describe the dependencies and how they relate to each other. I'm going to talk more about service levels in a minute, but you can extract metrics from your application and you can use those. If not in the wiki, then link to it from the wiki. Again, a service level dashboard is a great thing when you're thinking about service levels, but maybe you're really just trying to learn about this service. And in order to learn about that service, one of the things you might want to know is how reliable has it been lately? And so, like I said, wikis are a great way of managing this information, but don't think about humans as the only authors of it. Okay, why is documentation important? Well, to start off, this is really where service ownership begins, right? This is a record of who is accountable. And part of writing it down in a central place is so that everyone knows who's accountable. Everyone knows who the owners are. Another thing about this documentation is if we know it's up to date, we can actually use it to automate a lot of mundane tasks. Like I said, we build a lot of configuration based upon this documentation. And documentation is also really important for new members that join your organization, or when you have when people move teams within your organization. And lastly, I think documentation is really important in building confidence. The engineers that I've worked with, I mean, they're great. And one of the things that's great about them is they want to do a good job. And when I've asked them to take on new responsibility, they want to be confident that they're going to be able to do a good job in that. And so as we've started rolling out changes in service ownership at Lightstep, some of the friction that we've hit is really where folks don't feel like they have the information they need in order to do a good job of being on call. They haven't even been on call yet, right? But they're not sure about how it's going to go. And so documentation is really a way of giving them some of that certainty and making them more comfortable with those changes. And on call is different from a lot of other responsibilities that folks have, right? On call is unlike coding, even with your pair programming. On-call is really kind of a performance in some way, right? Like this is the moment when you have to get it done. And that's different from a lot of the other work that the developers and engineers do. And so on-call is one of the most stressful moments for a lot of engineers. Okay, so on-call, this is part 2. And maybe this is where a lot of folks start when they think about service ownership. Like I said, I think kind of building to it through documentation is important. The next thing you really need to do, though, is decide what on-call means in your organization. So maybe it goes without saying, on-call is responsible for incident response. But in organizations that I've been part of, on-call is often responsible for a lot of other things too. So deciding that for your organization is part of this. On-call might be responsible for communicating status of production internally or externally. They might be responsible for other planned changes to your production environment, whether it's deploying new code or making infrastructure changes. They might be doing some passive monitoring as well, handling sort of low urgency alerts or customer requests, other kinds of interrupt-driven work. And I think communication is a really important part of on-call, not only in the moment when an incident is happening, but in terms of shift handoffs, making sure that the next person is equipped to understand what they need to know, and as part of writing postmortems, right? So I want to talk about a couple pieces of these, but kind of thinking back to the beginning of when we went from a single on-call team and we split that up at Lightstep. The first thing was really to establish the need to split. Like, how did we know when that moment was there? And I guess the way that I've thought about this is really, you can survey, you can ask folks, where expertise is, you can ask them how happy they are about being on call. But you can also look at response time. And I think maybe most importantly, you can look at the number of people involved in a particular incident. And as that number gets bigger and bigger, I guess what that's telling me is that production incidents are involving information that's spread across the organization. And if it's taking a long time to bring those people in, that can be a risk for you. So these are all moments that we felt like are all things that drove us toward the moment when we decided we would split our on-call rotation. So here's a picture of all of the services that we needed to split. And so the way that we thought about this is, well, first of all, we want to get experts on the right rotations. That can be a challenge because expertise is complicated and overlapping in weird ways. We also kind of thought we could build in some shock observers through documentation. That was important as when we were finally successful with this. And then the last thing was to really balance the size of the rotation with the number of services. We actually had 4 different teams at the time, but rather than going straight to 4 different rotations, we actually went to 2. And even though those teams, each of those pairs of teams worked independently in their other work, we put them together for these on-call rotations because that meant that both we had sort of a reasonable number of engineers just to cover the time itself. And it also meant that the number of services that they had to learn about and understand was sort of the right size. Okay, so we've established the need for it. We've started doing it. So how can we help ease engineers into it? Well, the easiest way is actually just to make things better for them, right? Or help them make it better. And so as an SRE team, in this case, what are things that we can do across the organization to help do things like reduce response times or to make response better? What can we do to deliver alerts to the right teams? So this is kind of the first place in OnCall where I kind of think about telemetry and how we use it. And of course, this is a page that someone at Lightstep got a couple of months ago. And from here, you can go to the dashboard that kind of shows you this metric. But even better, we found, is to actually link directly to the trace, to evidence of what's going on here, not just in the particular service that's affected, but up and down the stack, right? Because that gives you context for not only how you might be able to reproduce this, but what are the other dependencies of the service here that might have been factors in the problem we see here. And this is really about automating some of the tribal knowledge, the knowledge that only a few people had, and through automation, making it available to everyone. Again, this is a way to build confidence, but ultimately it's about taking information that's in people's heads and using the telemetry itself to actually make that more available to others. The other thing I wanted to talk about, actually, there's a whole talk in this from last year's SREcon, but I think it's such a cool idea. I just wanted to talk about it for a minute, which is to send alerts directly to the teams that are in the best place to take action. One of the teams that I was on while I was at Google was pretty high up in the stack, and we would frequently get paged for problems that were not our problems. So I can remember one time I was on call, I got paged, I started grepping through some logs, and I think I had established that it was one of the other services and the other teams that we depended on. I got their engineer on chat. I started talking to them, trying to convince them what the problem was when they said, hey, sorry, I got to go. I've just been paged. I said, of course you've been paged. That's what I've been trying to tell you. Your system's not working. And really, that was a long and slow and very manual process to get that person up to speed and to get them involved in some way. And so the idea here is that we're actually going to use telemetry in the form of traces to do that automatically. So here's how it works. When an error alert triggers, we gather a bunch of traces that contain that error. It's probably pretty high in the stack if you're alerting on symptoms. That's great. But we don't want to just page that team. What we're going to do instead is we're going to look at all the dependencies of that service that had errors. And in turn, we're going to look at all of the dependencies of those services that had errors and keep going down the stack until we find services either without an error or without any dependencies. And then we're going to page those teams. Usually there's one, sometimes there's two. And we think, those are the teams that are going to be able to best respond. And that's good for two reasons. One is, we just saved a bunch of people some sleep. But we've also actually got the right people in the room much faster. So we'll be able to actually mitigate this issue much more quickly, just because the people that actually have the means to fix things are involved much earlier in the process. As I said, take a look at Luis's talk from last year. I think it's a really cool use of this information and a really cool way of thinking about essentially automating first responder responsibilities. Okay, I talked about these two things. The other way that we can kind of improve things for teams is to let them do it. When we divided up on-call responsibilities at Lightstep, we had a lot of low urgency alerts that maybe were important to someone when we had one on-call rotation, but it turns out that person didn't end up on the team that actually ended up owning that service and that alert. And so one of the first things that we did is just say to teams, like, look, if these alerts aren't bringing you value, go ahead and delete them. Like, that's up to you. That's really about how you're choosing to manage your work and where you think the value is. And the other thing is just let teams have other controls over the rotations themselves. Let them change the schedule to better fit their team and the way that they run the rest of their work. So maybe they want to do 7-day rotations. Maybe they want to do 3-4. Maybe they want to do weekday, weekends, whatever it is. Give them some control over that, because ultimately, they're the ones that are going to get these pages. Well, that's part of being on call that I want to talk about is postmortems. And you all know that postmortems are important and doing better next time. And obviously not just in making sure that issues were fixed, but really making sure that our responses are better next time, even if there's a novel issue. And really, maybe this brings me back to the first part of this presentation, which is postmortems are documentation, right? So make it easy, right? At Lightstep, we actually have two kinds of postmortems. We have what we call tiny PMs and then regular PMs. And we ask engineers, whenever possible, for any page or incident that we're responding to, at least fill out the tiny PM. And it's only a little bit bigger than what I could fit on the screen here. It's just a couple of questions about what happened and mostly multiple choice. And that allows us to gather information about what folks are doing while they're on call. And of course, for more significant incidents, we have a real postmortem with a timeline and a deeper explanation of what happened and things like that. If you write those things, make sure those are centralized too, right? I mean, one of the nice things about the form is all the information goes to the same place, but make sure all of those postmortems, no matter what team writes them, they all go to the same place. And make sure those action items and the other information is captured in a structured way. You don't want to lose those action items in some doc somewhere. Make sure that those are captured in your ticketing system, or better yet, make a wiki page and then, build a part of that wiki page that maybe runs a report that grabs those tickets using a label or whatever the right thing is. And of course, leverage telemetry in this. I think one of the things that's really important in a postmortem is that you're really establishing the truth of what happened, right? And telemetry is a great way of doing that. Okay, on-call is important. I don't need to argue with any of you about this. It has direct impact on customer experience, and whether that means revenue or reputation or something else. I think on-call is also important because time spent handling pages is not spent doing other things. And I think as maybe an SRE team trying to make the case to engineering leadership about new tools or maybe new processes or new responsibilities that you want to ask of the rest of the organization, this is a great way to motivate that to engineering leadership, right? Because again, time that folks are spending responding to incidents is time that they're not building new features and shipping those to customers. And then also, think about the morale of the organization as a whole, right? On-call can be a stressful thing, as I said, and making a good on-call experience can really have a big impact on job satisfaction. Okay. The last part of what I wanted to talk about today is service level objectives. And there's no way that I can do this topic justice in a couple of minutes. There's a book you should read about this. But let me just kind of give a little bit of an overview of it, because I think service level objectives are really, kind of how we define success for being on call, which I said is an important part of service ownership, and for delivering that service as well, right? And so I think it's worth spending a few minutes talking about them now. So SLOs, or service level objectives, are really just expectations for the service that you or that teams are providing. And those are expectations that their customers have. And those might be internal customers if they're serving to other teams within the organization, or they might be external customers. And there's a threshold built into these expectations that lets you report on whether or not you've been successful or whether or not you're failing over time or over groups of events. And it's really, I guess, the important part of this is thinking about an SLO as a means of communicating about how reliable a service is, right? And I sort of want to distinguish this from SLAs, or service level agreements, which are more legal contracts or agreements put into place with customers that have maybe real legal or financial ramifications for not meeting those. An SLO, I think we can really think of just in terms of, again, communicating what we expect to be able to do, and hopefully that lines up with what our users expect from us. So to give you an example, a really simple example, we might say something like, we want P99 latency to be less than 5 seconds over the last 5 minutes. So the first part here, P99 latency, is the service level indicator. You can think of that like a metric. There's a threshold, which is where we want it to be. And then we have some measurement window as well. And I'm simplifying things a little bit here because we might also talk about how often we want to meet this goal. We might not meet it all the time. In fact, in general, we want to aim for less than perfect, which is a little bit confusing when I talk about something like P99 latency, because now we might be trying to meet this threshold, say 99.5% of the time. And so we're both talking about a subset of requests in terms of their latency, and a subset of requests for which we really want to meet this goal. And I'm going to kind of leave off that second part, know that it's there and that it's important and that you should be doing it. But again, I'm just going to kind of focus on the description of what we're trying to achieve itself. There's a bunch of different indicators. Latency is one, error rate's one. Those are important for user-facing services. If you're streaming data, it might be about throughput. If you're storing data, it might be about durability. There's lots of different things. Again, it's what matters to your users. And again, being specific to endpoints or operations or even flows in your application. So, for you, it might not make sense to talk about latency for the whole app, because maybe there's just parts that users don't care that much about or don't notice. So really focusing on what are the key parts that users do care about, and whether or not they'll think that you're successful. Okay, so how do we determine these things? Well, we ask some questions, right? What do customers expect? We can do that through surveys, or we can look at product analytics maybe. You should ask what you can provide today. It's probably good to set SLOs in a realistic way. And then how do you expect that to change over time? And that can both be in terms of how you expect the organization to change in the software, right? Maybe you have a big set of releases and a lot of new functionality coming out, so you want to lower your expectations around reliability. Or maybe your users have different expectations about reliability over time. Maybe there's a big event coming up or a deadline in some way, and it's really important to users that service is more reliable during that time. These questions work really good for external SLOs, for customers that are outside of your organization. It can be a little bit trickier to do that inside, right? Because these SLOs have to all kind of fit together in some way. And so I kind of want to go through that as an example here. So say, to take a simple example, we've got these three services, A and B and C, and we've determined through whatever process that A should have an SLO of P99 latency less than 5 seconds. Again, there's some additional percentage of time that we're actually going to meet this. There's a measurement window. I'm just kind of glossing over a bunch of those pieces of it. And what we want to do here is try to figure out what are good SLOs to set for B and C, right? Because if we don't have them for B and C, it's going to be hard for the team that owns service A to understand whether or not that's a realistic goal for them. And so the way that I think we should be doing that is looking at traces, right? I'm going to put one here. Really, you should take a collection of traces, because those traces are really, again, going to tell you the causal relationships between these services and how they interact to answer these requests. So looking at this trace, the first thing is, again, kind of rounding here, that service B should probably have a similar SLO, because most of the time that A is processing this request, it's actually delegated to B. So if B can't have something that's much worse than that, or A is probably not going to be able to meet its SLO. And on the other hand, it might not make much sense for B's to be that much better, because it's not going to matter to A in this case. But it gets kind of interesting, I think, when we get down to service C, because B makes two different calls to service C, at least in this case. And again, we should look at some other traces. We should make sure it's always 2 and not sometimes 5 or 10 or 20. But in the case where it's 2, you might think that means that each of those 2 requests needs to take half the amount of time, right? We've got about 5 seconds here. We've got to make 2 calls. That's 2.5 seconds each. But the trick here is that 2 calls not only means that they both need to be shorter, but there's 2 opportunities for C to miss that threshold, right? And so we've got to actually give C a tighter SLO in some way. There's a couple ways of doing this, but one way is just to say that we have to consider a larger set of requests, not just 99th percentile, but 99.5 percentile. Again, there's other ways of doing this, but really the point is that we've actually given C a tighter bound in 2 ways, both in terms of the duration itself, but also in terms of the kind of level of reliability or the set of requests that we're considering. And this is all just so that we make sure that B can meet its responsibility as well. One of the other things that traces can help with here is actually it can or help us understand what we don't need to know, or what we're not learning in this case, is that maybe we also know that B depends on C for some set of requests, but not in this case. And so this particular trace, in this case, A's SLO, doesn't help us learn anything about the SLO for D. We've got to look elsewhere for that. Okay, why are SLOs important? Well, they're really, like I said, they're the measure of success in delivering service. So they're both important in terms of accountability, but teams can also use them as a guide in prioritizing their own work. So they're also part of this agency. If they've got a lot of their error budget left, if they've got a lot of room between where they are now and their SLO, that means that maybe they can take a few more risks. If they are getting close to that threshold, maybe they need to be a bit more careful. And really, the important thing here is that we're holding teams accountable in a consistent and a transparent way across the org, right? Again, include this in your documentation, both the goal and, as much as you can, the current values of this thing. Link to those SLO dashboards. This is a way for others to understand those SLOs, both so they can see that they're all being judged in an equal way, but also because they themselves will depend upon those other services, and they need to understand the SLOs of those services that they're depending on. Okay, to kind of review, I talked about the interaction of these sort of 3 puzzle pieces. That is, building documentation, the on-call process, and SLOs. And documentation is really, I think, the way that you're establishing ownership, right? It's kind of the on-ramp to that, and it's who you're going to hold accountable. And I think, what I tried to talk about is that documentation can be something that both humans and automations use, and something that can be written and created both by humans and by software systems as well. And really combining those, I think you get the best of both worlds. On-call, it can be more than incident response. And so figuring out what it means in terms of service ownership is really important. Using documentation and telemetry as part of not only investigation, but as you build automation and as you communicate about the on-call experience and about incidents themselves. And then finally, SLOs are really about how we measure success in delivering service, and about how we communicate about that as well. And the example I gave here of using tracing to help define SLOs for internal services. So kind of to leave you with a few next steps for moving forward, rolling out new processes like service ownership, rolling out new tools maybe that you want to use to support that is going to be hard, especially in these sort of distributed environments, especially if you're an organization that's adopted other DevOps practices. Those teams might have a lot of independence and autonomy in how they work. And so thinking about how these new processes and tools can provide value to those dev teams, right? This is kind of the carrot that you can provide to them to help them move forward. And ideally, I think one thing is really thinking about how to make these new tools and processes part of their day-to-day work, something they need to do every day. That'll allow them to become more familiar. It'll build confidence in them. It'll become part of the routine. And if it's something that they only use, once a month, it's just going to be something that you're going to have to really work hard to get adopted. And so, I talked about using documentation as sort of a ramp, but really you can think about that as a way of manufacturing this need to use it in a day-to-day way. That is, like this example I gave of our services.yaml, it's part of how engineers get work done. So it's something they have to be familiar with. And therefore now we can leverage that, our foundations team can leverage that in other tooling that they built. And finally, giving teams a budget for improving documentation, for improving things like alerts and other parts of the on-call process, and improving the reliability itself, right? If they have that agency, that control, that'll be another and a good reason for them to adopt these things. Okay, so just to sum up, I talked about ownership as really having these two halves, not just holding people accountable, not just making people responsible, but also giving them agency to make things better, giving them the budget to do that. And when we do that in terms of accountability, setting goals for those service owners and judging their performance based upon those goals, and doing that in a consistent and a transparent way across your organization. And then for the agency as the SRE team, offering them information, offering them the confidence, the budget, maybe the tools that they can use to pick up to actually improve, not only the reliability and the quality of their service itself, but the way that they work as well. And really, telemetry provides key information to both of these things. It's part of the way that we measure whether or not teams are meeting their goals, and it's part of that information that they can use to make things better. So with that, I wanted to thank everyone for your attention. And if you have any questions, you can find me on Twitter at @save_spoons. Thanks again.